Right. The 11th question in kinetic theory of gases is, at what temperature will the RMS speed of oxygen molecule becomes just sufficient for escape from the Earth's atmosphere? This question might be derived from kinetic theory of gases. Okay, from the kinetic theory of gases, first you can derive the relation between escape velocity and absolute temperature. So, from KTZ, what is that? From kinetic theory of gases, pressure exerted by the gas molecules on the walls of the vessel. What is that? 1/3 mn square of mean velocity. Here n is equal to what? Number of molecules per unit volume. That implies this equation is written as 1/3 m into n is equal to what? N by v into v bar square. That implies when v is brought into the side, that implies pv is equal to 1/3 m n v bar square. This is equation 1. And from ideal gas equation, what is that ideal gas equation? pv is equal to what? N into r into t, isn't it? Here n is written as number of molecules by Avogadro number, n naught, and r is written as Boltzmann constant into Avogadro number. So these two are substituted in this equation. Therefore, PV is equal to, n means n by n naught into r is equal to Kb into n naught into absolute temperature. To see in here, n naught is cancelled. That implies PV is equal to n into Kb into T. This is equation 2. To see now from equation 1 and 2, you may equate PV. That implies, therefore, 1/3 mn v square is equal to n into Kb into T. On both sides, n is cancelled. Okay, that implies, we may write v bar square is equal to 3 brought into the side, 3 into Boltzmann constant into temperature, absolute temperature by mass. So when you write only v bar, that implies it is nothing but what I say, mean of square velocity. So this is relation between square of mean velocity and absolute temperature. Based on this, we can now derive the required. What is that? V, that means required velocity. Sorry, what is that? V is the escape velocity on the surface. Here, escape velocity on the surface is nothing but what I say, of Earth. What is that? 11.2 kmph, which may be write as v bar is equal to 11,200 meter per second. Now substitute all the values in this equation. Therefore, 11,200 is equal to under root 3 into Kb is what? Boltzmann constant, already given. What is its value? 1.38 into 10 power minus 23 into absolute temperature by mass of, here m is the mass of oxygen molecule. Already it is given. What is that? 2.76 into 10 power minus 26. Okay, now you should calculate T. Then finally you get the answer while doing calculation is 8.360 into 10 power 4 Kelvin. That's it.